This is the engine behind a $1.7 trillion fighter program.
Imagine a single engine powerful enough to lift a 40,000-pound fighter straight into the air.
Then seconds later, push that same aircraft beyond the speed of sound.
This is not science fiction. This is the Pratt & Whitney F-135. The engine at the heart of the F-35 Lightning suit.
A machine anchoring a fighter program worth over $1.7 trillion.
But how do you compress that much power into a single engine?
And how does it survive conditions that would destroy almost any other machine?
To answer that, we have to go inside. The F-35 is often called the most advanced fighter jet ever built,
propelling a $1.7 trillion investment into the future. Stealthy, networked, lethal.
But none of that matters without thrust.
Hidden deep inside the aircraft is the F-135 Turbofan, an engine that doesn't just propel the F-35 forward, but defines what the aircraft can do.
Unlike older fighters, the F-35 was designed around its engine, not the other way around.
Every system bends around the F-135's size, heat, and airflow.
This engine is the structural and operational core of the aircraft.
On paper, the F-135 produces over 40,000 pounds of thrust.
But numbers don't tell the full story.
That power means instant acceleration.
Sustained supersonic flight.
And the ability to carry heavy fuel and weapon loads.
For the F-35B variant, the challenge is even greater.
The same engine must redirect its power downward,
allowing the aircraft to hover and take off from short runways.
No other fighter engine in history has been asked to do this.
and yet the F-135 does it reliably in combat conditions.
Compared to older fighter engines, the F-135 is physically larger and heavier.
To survive, engineers rely on advanced superalloys.
How much thrust it produces relative to its size.
Older engines were built for speed or agility.
The F-135 is built for everything at once.
Stealth, range, vertical lift, electronic systems, and raw thrust.
That balance comes at a cost. Which raises the next question.
Extreme heat, pressure, and mechanical stress. Inside the F-135, temperatures exceed the melting point of ordinary metals. To survive, engineers rely on advanced superalloys.
Ceramic matrix composites and heat-resistant coatings.
Materials designed to withstand extreme heat and pressure.
Turbine blades are filled with microscopic cooling channels.
Thermal barrier coatings shield metal from direct flame. Some components are built layer by layer using additive manufacturing, allowing shapes impossible to machine by hand.
Every part is tested, stressed, and often destroyed.
Just to understand exactly how it fails.
Because in combat, failure is not an option.
Durability is engineered from the very beginning.
The engine is pushed through thousands of stress cycles.
So it can survive years of extreme flight.
Before it ever flies, the F-135 must prove itself. Before an F-135 engine ever flies, it is tested relentlessly.
It is run at full thrust, again and again.
Often pushed beyond its operational limits.
Exposed to vibration levels that simulate years of flight. And held at extreme temperatures for extended periods.
Thousands of parameters are monitored in real time.
Engineers search for microscopic cracks and thermal fatigue. Even the smallest anomaly is investigated. Engines that fail any test are pulled from service. Only those that pass every test are cleared to fly.
And even then, the testing never truly ends. Every flight feeds back into the validation process.
Reliability is proven through repetition.
Thousands of hours before combat deployment.
Because reliability is the true measure of power.
But raw power alone is not enough.
The F-135 is governed by a full authority digital engine control. A computer system that controls every aspect of the engine. The pilot doesn't directly control the engine. They make requests, and the FADEC decides how to respond.
It reacts faster than any human ever could.
Correcting problems before they become failures. Continuously balancing power, efficiency, and safety. In modern air combat, software is just as important as steel.
And engine control affects more than performance.
The F-135 doesn't just produce thrust.
It has to do so without giving away the aircraft's position.
Exhaust shaping helps reduce infrared and radar signatures.
Heat is carefully managed and dispersed.
The engine's placement affects every interpol system.
Including internal weapon bays. Airflow paths must be carefully controlled.
Even stealth coatings are influenced by engine heat.
Nothing in the F-35 exists in isolation.
Every design decision echoes across the entire aircraft.
Today, F-35s operate across the globe. Each mission depends on the reliability of its engine.
Behind every flight is a massive logistics network.
F-135 engines are constantly inspected and maintained.
Upgraded and refined throughout their service life.
Data from every flight feeds back into performance models.
Improving future engines before they even fly. This is not a single machine.
It is a living, global system.
And its impact goes far beyond the aircraft itself. The Pratt & Whitney F-135 is more than an engine. It represents what happened when engineering pushes past traditional limits.
Combining brute force, digital intelligence, and extreme materials.
For decades to come, it will define air dominance. A testament to precision, power, and human ingenuity.
Behind every mission, the engine waits.
Designed by thousands of engineers over decades.
Refined through years of testing and iteration.
Built through failure, correction, and relentless precision.
Now supporting fleets across the world.
Trusted with lives, missions, and national security. Every pilot depends on a machine they cannot see.
Quiet at rest.
Violent when unleashed.
A controlled explosion, harnessed by design.
A balance of physics, materials, and intelligence.
Setting the standard for future engines. It will remain in service for decades.
Shaping the balance of air power worldwide.
All of it driven by a single engine.
same engine that lifts a fighter straight into the sky.
And pushes it beyond the speed of sound.
Power, carefully controlled. Precision without compromise.
A product of human ingenuity.
Built to endure the impossible.
Flight after clear.
Mission after mission.
From a single engine to global air dominance.
This is the Pratt & Whitney F-135.
The engine behind the F-35 Lightning II,
At the center of a $1 trillion program. A machine built not just for power,
but for dominance, reliability, and survival.
Because in modern air combat, the engine decides everything.
And this engine sets the standard for a generation of flight.